Hello friends, welcome back to our YouTube channel. Today I would be explaining you how you can analyze and design a simple RCC beam in Staad Pro. So friends, let's start generating a simple RCC beam. First we'll go to new project, then space, selecting our units as meter and kilonewton. Okay, add beam. I'll change my default grid spacing to XZ plane. Okay, I want to make a beam of size, let's say let's say 8 meter. Okay, I'll escape. Then what I will do, I will assign a property to my beam. Suppose a beam is of 500 mm depth and width of 0.3. I'll select my material as concrete and add. Now I'll assign it. Our property assignment is complete. Now I will provide support here. We will be making a simply supported beam. So I'll create pin support here and I'll assign the support to both the ends. Now I'll be putting some load over it. I'll add my loads. So first load I will be selecting the self weight of the beam. Okay, I will assign it. Then what I will do, I will use one point load of 20 kilonewton. I'll use a point load of 20 kilonewton, but if I use this command, then I have to create a node. But since I don't want to create a node, I'll not use this one. I'll make it 0 and I'll go to member load and I use this concentrated force load minus 20. Okay, and at what distance I want? Suppose this is 8 meter. I want it at a distance of 4 meter. Okay, in global y direction. So I will put it like this. So it will be coming at load is applied at 4 meter. I think this load is quite heavy. Let me reduce this one. Let me take it as 5 kilonewton. Okay. So guys, I'll be assigning one more load to it. Let us assume that it is having a UDL of 2.5 meter at 2 meter distance from here. Okay. I'll show you how to do that one. It is member load. We will be selecting uniform force minus 2.5. Why I am getting minus is because so that the load will be applied in the downward direction. So 2 meters from here. So D1 is 2 and this what will be the length of my UDL? So let's say I will take it 3 meters. Okay. So my UDL will be applied after 2 meters up to 3 meter length. I'll add it and I will apply over my beam. Right, I'll get like this. Now what I will do is I have applied the load. Now I will analyze it. Okay, let me analyze. I'll add perform analysis. Then I would run my analysis. I'll go to post processing directly. So in post processing, what will be, I'll do this one, safety. What we will see first, let us see what is our bending moment. So this, since it is a simply supported beam, so our bending moment will be like this. Now let us see what is the shear force. This is a shear force diagram. I will also open bending moment diagram, and what I will do is I will see the value, what value this moment, what is the value of moment here, what is the value of shear force, view values, beam results, bending maximum I will do, shear force I will check the maximum values, what is the maximum shear force it is coming. So my bending, my maximum shear force is 18 meter. So let's say I want to see here also. I will do what? I'll do, I'll ends also. I'll also do end, but bending moment at we know that it will be 0. So my shear force here, it is minus 17 and it is 18. And our bending moment is 41, right? We can see our bending moment, it is coming out to be 41 here. At a distance of 4 meter. In the mid, it is coming out to be 41. So this one is our analysis part, in which we can get the bending moment and shear force value of our beam, and we can also see what is the axial force that is coming over the beam. It is nothing, our axial force is nothing because we didn't apply the axial load, but we can see our axial force from here. Okay guys. Now let us design this beam using Staad Pro. What Staad Pro gives. You can manually design it also, but you can manually design it also if you have any spreadsheet. You can extract the forces from here, bending moment and shear force from here, and you can manually design those with your spreadsheets or Excel sheets. But since we are having a tutorial over Staad Pro, so we will be designing this beam through Staad only. So now I'll click on design command and I will be selecting my code as IS456. Okay, we are in steel. We have to go to concrete. IS456. Well, then what I will do, I will define some parameters for my design. Suppose what is the clear width that I required. Suppose our beam is having a clear cover of 30 meter, then I would be inputting this 0.03 meter. I will add it. What is my grade of concrete? Suppose my grade of concrete is 30 M30, then I will be putting 30,000 here. What will be my uh, suppose my main steel reinforcement grade is 415, sorry, 500. Let me take 500. 500. I'll add this secondary also. It is at site, it is use only 500. Okay, 500. Okay, three zeros are there. Add. Then what is the maximum dia of reinforcement you want to use? I want to use, let's say 20 maximum dia. Is this one is you want to check clause number 25 of IS-456 considering minimum eccentricity, then you can also apply this one. We will not use these others. Ratio also, maximum longitudinal reinforcement. You can keep your value also, but let it be 4 only. Then okay, it is designed for 1000. It is taking default value. We will not add it. Track. What we will do is I'll select 2 because I want detailed beam design. I want to it will be beam design track 1. Track 1 means this one, intermediate level, column design, track 0, and all that one. Point number 2 will be detailed design. I'll add this one. Okay, now I will go to command. I'll add design beam and take off. If I want to get the concrete quantity and all. This is for getting quantity of concrete and steel. Okay, I'll assign these to my beams. I will assign all these to my beams. Now I will run the analysis again. I'll go to post processing. I'll select on this beam and I will double click here. I'll get my beam design. So Staad is doing like this. Staad is putting 4 bars of 10 dia at top, 4 bars of 10 dia at bottom, and it is put. These are the shear reinforcement it is putting. We can also get the output file. We can also get this output file of concrete design. At each section, it is showing of reinforcement top and bottom, and what will be our shear reinforcement. This is our takeoff sheet. How much quantity it is used. It is there. If you do like my videos, please like, share and subscribe. Also hit the bell icon for latest videos. Thank you and goodbye.